Okay guys, we'll be looking into some of the examples on calculating the double bond equivalent or DBE of the following organic compounds. Okay, so let's take some examples. So the topic is calculation of DBE. So I hope you remember the formula for calculation of DBE, and I also talked about a smart trick to calculate the same. So just in case if you have forgotten that, the formula is dB is equals to C plus 1 minus H plus X minus N by 2, where C is the number of carbon atoms, H is the number of hydrogen atoms, X is the number of halogen atoms, and N is the number of nitrogen atoms. The trick was just to calculate the number of pi bonds or ring in the compound. So the number of pi bonds or the rings in the organic compound will get you the dB of that organic compound. It's that simple. Okay, let us look at some of the examples for calculating the same. So C3H6. So in this case you don't have a ring, or you don't know how many number of pi bonds are there, so it's better to apply the formula here. So according to the formula, it would be 3 plus 1 minus H is 6 plus X minus N by 2. So I think that would give you answer 1. Okay, CH3N, I think dB would be C would be 1 plus 1 minus 3 plus 0 minus 0 upon 2. That would H plus X minus 1, N is 1 here, so that would give me dB is am I missing something? CH3N and minus 1, so dB of 1 plus X minus N by 2. Okay, so C is 1 plus 1 minus 3 plus 0 minus 1 by 2, so that would be 2 by 2, 1, and so answer would be 1. Okay, dB for this. So according to the formula, it would come C plus C6 plus 1 minus a number of hydrogen atoms are 1 2 3 4 5 6 7 8 9 10. So 10 plus 0 minus 0 upon 2, it would come as 2. Or even if you use the trick for this given organic compound, the number of rings was 1 and the number of pi bonds is also 1 between the C and the oxygen atom, this one. So 1 pi bond and 1 ring, so answer would again be 2. Okay, let's look into this example, C10H10. So for C10H10, I think you should calculate this on your own and tell me what the answer is. I'll write some of the examples here in which you must do the necessary and should come up with the results. Okay, H10O, this is H10O. Okay, so you need to calculate the dB for all of these written following compounds. So if your answer was 6 for this case, then you are correct. So simple reason is it would be 11 minus 10 by 2, which is 5. So 11 minus 5 is 6. Okay, C8H8, if your answer is 5, then you are right. So simple calculation, 9 minus 8 by 2, which is 5. Okay, now for this case, if your answer was 0, then you are right. For this case, 2, this one, Okay, let me just calculate for halogen atom as we are first time encountering this type of problem. So it would be 5 minus 3 plus 1 by 2. So it would be 2. 5 minus 2 is 3, or am I missing something? So just looked into the problem. So I think there is some correction over here. So it is not the compound we are looking for. The compound actually has H9 H atoms. Okay, so now again calculating a DE or DBE, we can get 4 plus 1 minus 9 plus 1 by 2. It would be 0. Okay, so what is the value for C3H6O? If your answer is 1, then you are correct. Okay, so now use our trick to calculate the DBE directly for the following compounds. What would the DBE for this compound? Let's just write all the questions at once, and then we can delve into each example separately. Meanwhile, while I'm writing, you can just think about what would be the DBE of this by just using our trick, that the DBE of organic compound is the number of pi bonds, or the number of rings the compound actually has. Okay, so let us calculate DBE for this compound. DBE would be 3. Why? Because we have 2 rings over here, one first ring, second ring, and a double bond. Okay, so the answer for this case is 3. Answer for this case is we have first ring, second ring, and 1 2 3 4 5 pi bonds are there. So 5 plus 2 rings, the answer would be 7. For this case, I think first ring, second ring, and third double bond, the answer would be 3. Okay, similarly for this case, we have first, 1, second, 1 2 3 rings. So the answer for this case would be 3 plus 4 5 6. Is the answer 6? No. Why? We have not incorporated the DBE for these two functional groups. So when you expand CHO is nothing but C double bond OH, and this would be the ring structure somehow. So we have not included this 1 pi bond. So 6 plus 1 plus, is the answer still okay? No. Why? Because we have not expanded this CO2H. So CO2H is internal structure is C double bond OH, and this is the ring structure. Right, so there is one more pi bond here, so plus 1. Total answer would be 8. So this, okay, let us take some more examples over here for the calculation of the DBE for bicyclo and spiro compounds. Okay, so now if you take look into this structure, you need to calculate the DBE of the following structure. What would the DBE of this structure? The DBE would be 2. Why? Because when you closely look into this bicyclo compound, you can see that these are the 2 carbon atoms which are common for 2 rings. The first ring is this one, including the carbon atom which is drawn as the peak atom, and the second ring is this one. Okay, so let me redraw the ring so that it becomes more clear to you. So the first ring was, this were the 2 carbon atoms, this one, and what was the second ring? The second ring was, okay, let me have some redraw it with some space. Okay, the second ring was this was the second ring, right? So these carbon atoms, these two carbon atoms actually contributed to this lower ring, and the upper ring was these carbon atoms. Okay, so let us take some more examples. So the DBE for this thing is, for this compound is 2, because we can form 2 rings out of this structure. Okay, let us look into calculation of DBE for this pyro compound. So what would the DBE of this compound? This is the first ring, this is the second ring, so the DBE would be 2, as the rings are 2. Now let us look into the structure. So DB for this compound is clearly 4. Why? First ring, second ring, third ring, and fourth ring. So DB is 4 for this compound. Okay, so this brings us to the end of calculation of DBE lecture. Okay, in the next lecture we'll be starting off with some more examples on how to find out the total number of functional groups in an organic compound, and also some calculation of DBE in those compounds which have substituted functional groups within them. Okay, bye.